This conference will now be recorded.
Right, let's start today's session. In the last session, we started with multi-threading programming, and in that we discuss what is multi-threading. If we go with multi-threading program, what is the advantage, and also difference between single-thread program and multi-thread programs we discuss. Clear difference is there, single-threading program and multi-threading program. The main difference is single-threading program and multi-threading program is saving the time. Okay, execution time. So when we go for parallel execution, obviously we will save the time of the execution so that we will get quick response from the output window. So next, uh, today we'll discuss about how many possible ways to create threads in Python. Okay, what are the possible ways to create threads in Python? So there are three different ways to create threads in Python. One is creating thread by using without using any thread class, creating thread by extending thread class, and creating thread without extending thread class. These are all the options are available. Okay. So I think we have shown one option already, creating thread without using any class. Okay. Let's open the project here. Just wait, I'm just opening the project here. Yes, we already discussed creating a thread without using any class. Now in this example, you can see there is no class is available. Did I maintain any class here? Observe here. There is no class is available. So class is not available. So that means creating a thread without using any class. There is no classes available. So just we create a function, and in this function just I have written some logic, like for I in range of 10, 10 times this loop should be iterate, and each time it has to display child thread because this program is executed by child thread only, that is T only. T is a child thread name. And behind the scenes, every program executed under one thread, that is main thread. Main thread executes this program. For I in range of 10, this is the main thread only. Got my point? So for I in range of 10, print main thread only clear. This is the main thread. So this is what actually here, uh, this program executed by main thread, this program executed by child thread. This is creating thread without using any class. Next, creating thread by extending thread class. Okay, let's go for other way of creating thread. Thread 3 program I'm showing. Thread 3. Thread 3. Creating thread by extending thread class. So I'm just copy and paste it. Creating thread by extending thread class. Creating thread by extending thread class, we can say that. Creating thread by extending thread class. Creating thread by extending thread class. Now, in this case, okay, so if you want to create a thread by extending thread class, we have to create child class for thread class, sir. First, what we have to create? We have to create child class for thread class. We have to create child class for thread class. You have to create child class for thread class. In that class, we have to override. We have to override. We have to override run method. We have to override what method? Run method with our required job. With our required job, I can say that, with our required job. Whenever we call, whenever we call, whenever we call start method, whenever we call start method, then automatically, automatically run method, run method will execute, run method will execute and perform our required job, perform our required job action. This is the case. So while creating thread by extending thread class, we have to create child class for thread class. And in that class, we have to override run method with our required job. Whenever we call start method, then automatically run method will be execute and performs required job. I can say that run method will execute and perform required job, required job. Okay. So let's try to create one child class for thread class, because I said that we have to create child class for thread class. Creating a thread by extending thread class means we have to create a child class from threading import star. I'm creating a child class. For example, my thread is a class. My thread is a class. My thread is a class. This class is inherited from which class? Thread class. So thread class is a built-in class, sir. Okay, thread class is a built-in class. This class is inherited. This class is coming from threading module, and this class name is my own class name. Creating thread by extending thread class. So in this case, we have to create child class for which class? Thread class only. Yes, I created child class. This is child class. For which class? Thread class. We have to create child class for thread class. So class my thread of thread class. Okay. So def run method is there. In this method, in that class, we have to override run method with our required job. So I'm overriding run method with our required job. Run method is there. With our required job means whatever you want, you can write it. For I in range of 10, I'm taking. Print what actually? This is a child thread 1, child thread 1, child thread 1. Now coming to this here, we have to create object for class. What class? My thread class, because this is thread class only. Once this class is inheriting from thread class, predefined thread class, it will become a thread class only. So t equal to my thread. So whenever we start a t dot start method, when we call start method, automatically run method will execute and perform required job only. No? Yes. So same whatever I have written here. We have to create child class for thread class. Yes, we create a child class, sir, for this thread class. And in that class, we have to override run method with our required job. Yes, we are overriding run method with our required job. This is my required job. Whenever we call start method, automatically then run method will be execute and perform required job or not. Yes, when we call start method, automatically run method will execute and then perform required job only. This is t dot start method. So let's run this once. Now you can see we are having this execution child thread 1, child thread 1, child thread 1 is executing. Now this is what run method through here. So this is second option, how to create threads. Creating a thread by extending thread class. Creating a thread by extending thread class only, sir. Okay, we are creating a thread by extending thread class clearly here. Okay, yes, next option is there, creating a thread without extending any thread class. Option number 3. Option number 3, creating a thread 4 I'm taking. It's my example name. Now you can see creating a thread without extending thread class. Without without extending thread class, I can say. Creating a thread without extending thread class like this. Creating a thread without extending thread class. Now I'm taking class. Class name is test. Okay. So first, before that, I'm trying to import the namespace like from threading import star and class test. In this class test, what I'm trying to take, def display is a method. This display method is having parameter like self parameter. And now you can see for I in range of 10, I'm taking. Okay, then print child thread 2 or 1, I'm taking child thread, child thread, child thread, 1 only. Child thread just that is. Now you can see I have a class called test class, but this is not a thread class. It's a normal class. Creating a thread without extending thread class. Without extending thread class means I'm not extending any thread class. This is my class only here. In this class, we have a display method. Display method. In this, I have a loop called for loop. I want to execute this for I in range of 10 child thread. Now we have to create object for which class? Test class. Now let me create object for test class. T equals to test. It's normal object creation for our class. But is this thread class? No, it is not a thread class. Okay, test is not a thread class. It's a normal class. T is an object of test class only here. Okay. Next, we have to create object for thread class only. How to create object for thread class? So thread object is T1 equals to thread is a class. I want to target which function here? Display function. But whenever I try to write a display function, it will not possible because let me show you. Target equal to display function I'm calling. Display I'm calling. Display. But display function, where it is there? Display function is not there directly as a normal function. If it is normal function, directly you can call. Like in previous example, thread 2 program. Now you can see here, this display F1 function is directly available so that we are calling target equal to F1 only, simple. But in this program, this display function directly not available. It's available in where? Inside the test class, inside the test class. So inside the test class, this display function is available. So in this context, what we have to use? So this display function cannot access directly inside the thread class because who will represent this class? T is a representation of the class because T is an object of test class. So to call this method, first you have to consult with this T. So that's what I'm taking T dot display. This is the calling of method. T dot display only. This display method don't have any arguments, so no need to include any args equals to something like this. So T1 is a thread object dot start method. That is fine. So creating a thread without extending thread class. So I'm not at all extending any thread class. In previous example, look at here thread 3. I create a class. This class is extended from thread class. So this is the example creating thread by extending thread class. But this example, I create a class, but this class is not okay extended from any class, thread class, only normal class. I create object for normal class, and using this object through, I'm representing this display function in target attribute t dot display. T is a normal class object. T1 is a thread class object. This is my child thread one only. So these are the options are there. Okay, how many possible ways to create threads in Python programming? You can use the options like this. These are the options are available. Okay, creating threads by extending thread class, creating thread without extending thread class, creating thread without using any class. These are the options are available to creating threads in different ways in Python. Okay. Now, coming to this, there are so many methods are there here in multi-threading programming. So many methods are there. First, So many methods are there. So what are the methods and properties are there? Let me check that. First of all, I need to discuss about thread identification number. Every thread is having its own identification number. That concept is called thread identification. Thread identification number. Thread identification number. Thread identification number. Thread identification number, how we can find out? So for every thread internally, a unique identification number is available. Okay. For every thread internally, a unique identification is available internally. A unique identification is available. Okay, we can access, we can access that ID, that means thread identification number, by using implicit variable, that is ident. Ident is an implicit variable only. Using this ident implicit variable, we can access that thread identification number. For every thread internally, a unique identification is available. We can access that unique identification by using implicit variable, that is ident. That is what ident only. For every thread internally, a unique identification is available, sir. For every thread internally, unique identification is available. So that ID, if you want access, then ident implicit variable we have to use. And this identification number we can find for main threads as well as child threads also. Because by default, every Python program is having main thread, no? That main thread also can have the identification number. Child thread also can have the identification number. Let's find out that. Now you can see. Now you can see thread 5 I'm taking. How to get the identification number of main thread as well as child thread. Okay, and every execution to execution identification number will be changed from threading import star. From threading import star. def f1 function is there. F1 function. Okay, printer. What I'm trying to say, child thread I'm taking. Print child thread. This is my function name. And I want to create one thread, child thread, which is targeting my function called f1 function. This is the child thread only. And child thread need to be start. Yes, it is starting. And I want to find that main thread identification, child thread identification. First, main thread identification. Current thread dot ident. Current thread means it is pointing to main thread only. Currently, this thread 5 program is executing under which thread, that is going to be find. Current thread dot ident variable is there. To find child thread identification, then we have to use child thread identification. Child thread identification. Then child thread identification is what? T. Okay, child thread identification is T. T dot ident, we can say that. Like this. So now you can see this run and child thread identification, main thread identification. Now you can see main thread identification is what? 4952. Child thread identification is 12840. 12840. Every execution to execution, main thread and child thread will be different. Now you can see child thread, main thread identification is what? This is main thread identification 1456. Child thread identification 944. This child thread is just this output only. This child thread is first one, this output here. And after that, main thread identification is 1456, child thread identification is 944. Now you can see here, child thread, main thread identification 7540, child thread identification is 10696, like this. So this is just for identification, because multiple threads will create, no, for our programs. But every thread is having its own identification number. That is called child thread and main thread identification number. You have to recognize that threads are separately independent with each other, no? I said. So that's what it's having its own identification number. Next, we have one more method is there, like active count method is there. What method is there? Active underscore count method is there. This method. What is the use of this active count method here? Okay. What is the use of this count method here? Active count method. So this function, active count method, this method, this method, this method is used to, this method is used to uh, find number of active threads currently running. This method is used to find the number of active threads currently running. Number of active threads currently running. Number of active threads currently running, I can say that. This method is used to find the number of active threads currently running, like this. Give me 1 second. Active count method is used to find the number of active threads currently running in your program. It is used to find how many number of active threads are currently running. This is also a simple program. Let's go for quick example. Thread 6 I'm taking. From threading import start. And now I'm trying to import time also, time module. After that, I'm creating one function called F1 function. This F1 function I want to target with a thread only. So first let me print current thread is my function name dot get name, get name, get name. Then I can say started, means which thread is started. And after time period waiting, like sleep of 3 seconds, again I'm trying to say current thread dot get name, get name, started, like this, started. Okay, df f1 function. So f1 is a function. Okay, current thread dot get name, current thread dot get name here, started, ended. Sorry, it is. Next one is ended. First, whatever thread is started, that is started here. I can say ended. I can say that next, ended. F1 function started and ended. Def F1. Okay. Now here I'm printing what I printing, the number of active threads. The number of active threads. The number of active threads. So what I have to do, active count function will do that. Number of active threads is will found. This function will find number of active threads. But let me create T1 thread. T1 is one thread which is targeting what function, F1 function. Okay. And here we can also give the names of the threads also. Name attribute is their name. Which thread is active right now? Child thread 1, I can say that. Child thread 1. Because this is child thread 1 only. So child thread 1 name, this name is going to be here. Child thread 1, current thread started, child thread 1 ended, child thread 1 started, like that I want to display. Like this, many threads I want to prepare, like multiple threads. Target equals to F1, name equals to what actually? Here I'm taking child thread 2 only, child thread 2. Next, T3 equals to thread class target equals to F1, name equals to child thread 3, child thread 3 like this. Child thread 1, child thread 2, child thread 3. Target F1, target F1, target F1. T1, T2, T3 like this. Now next what I'm trying to do, T1 dot start, T2 dot start, T3 dot start. Now finally print after execution of threads also the number of active threads I want to find. So in that context, what I'm trying to take, this is number of threads, this is active number of threads. The number of active threads, active count, and after time period only, here you can see time dot sleep off, time dot sleep off. How many seconds I'm waiting? 5 seconds. And again, after waiting 5 seconds, again I want to count number of active threads, how many are there. So the number of active threads right now, how many you can see is first, for the first time whenever we execute this function F1. So this function, when it will execute, tell me, when we call this function, then only this function will execute. But where you are calling this function? Here, T1 thread 2. When we call this T1 dot start, then T1 thread will execute, starts, target is F1 function, then only F1 function will call. But before calling the F1 function, which line of the code will execute? Ninth line will execute, because this ninth line is not belongs to F1 function. It is out of the F1 function. So initially, first the number of active threads, how many, 1. Why sir 1? Because this total thread 6 program is executed under one thread, that is main thread. So main thread active count is 1 only. After T1 start, T2 start, T3 start, total 3 child threads are going to start at main thread plus second, third, fourth. So total active threads are here 4, because 3 child threads are there in my example, T1, T2, T3, and one main thread is there. So total number of threads are how many? 4 threads are there. 4. Total number of threads are 4. So here 4 threads active count, and after that sleeping 5 minutes, 5 seconds sleeping time. Then total number of threads are what actually here? Again 1 only, because after T1, T2, T3 ended, only one is active mode. So ultimately, just active count function will return how many threads are going to be currently in active mode. You will find, look at here, there is deprecation warnings are there. Let me clear the deprecation warnings first. To clear the warnings, you know how to do it. Import warnings. Okay, import warnings. Then what we need to do here, warnings dot filter warnings, then I'm taking ignore. Then what we can say, import warnings dot filter warnings, ignore. Which category of the warnings you want to ignore? Category is what actually? The category is deprecation warnings only. Deprecation warnings. So now you can see the number of active thread initially 1. Child thread 1 started, child thread 2 started, child thread 3. The number of active threads started, number of active threads 4. Again, child thread 1 ended, child thread 2 ended, child thread 3 ended. Number of active threads 1 only. Let me execute. So output will be not properly. The reason is in multiple threads programming, don't expect output in orderly, because parallel execution is possible. Now you can see before going to start T1, T2, T3 threads, number of active threads is one only. The reason is main thread only executing this program right now. After child thread 1, child thread 2, child thread 3 started after, then including 1 plus 3, child threads are there. Total active threads are how many? 4 threads are there. And child thread 1, 2, 3 ended after, then number of active threads again what? 1 only. So ultimately main thread is always it is executing the program, and along with main thread, 3 threads also running behind the scenes, child thread 1, child thread 2, child thread 2. Whenever it is ended, then main thread only it is active right now. This is the program to find the number of active threads in our program. Next, one more method is there, that is called is alive method. What method is there? Is alive method. There are so many methods are there. Is alive, is underscore alive method is there. This method is used to check whether a thread is still executing or not. This method is used to check whether thread is still executing or not. Whether a method still executing or not, we can say that. This method is used to check whether thread still executing or not. Thread still executing or not, and thread is alive means if it is still executing, is alive method will return true. If thread is not executing, is alive method will return what? False only. If your thread is still, it is running the program inside the program, still executing that, then is alive method will return true. If not executing, simply is alive method will return what? Actually false. Is alive method will return false actually. Okay, this is alive method. Is alive method checks whether a thread is still executing or not. It will check is alive method. Let's try to figure out this. Okay, is alive method, how to work it. So same program I'm converting into is alive method. Look at here, import time f1 current thread dot started, current thread dot ended, and only here you can see t1 t2 threads I'm taking. Number of active threads I'm not going to find in this example. Okay, number of active threads I'm not going to find. After T1 start, T2 started, then what I need to do, just observe here. Here I'm going to extend. I create same program. Import threading, import time, function name, current thread dot get name started, time dot sleep of 3 seconds, current thread dot get name ended. T1 thread is there, T2 thread is there, target is F1 function, name child 1, name child thread 2. Now here I'm trying to find which thread is in active mode. T1 dot name means child thread name is alive. True or false, I want to say that. So how I can say true or false? T1 dot is alive method I'm taking. This is the method, sir. Is alive method. Next print T1 dot T2 dot name, sir, here. T2 dot name, comma, is alive, colon, T2 dot what actually? Is alive. T2 dot is alive only. Is alive. Now you can see time dot sleep. Time dot sleep. Of 5 seconds I'm waiting. After waiting 5 seconds, again I have to check whether thread still alive or not. Let me copy this code again and place into here. So after 5 seconds, thread obviously will end. So again, this is alive methods will return false only. First, whenever thread started, is alive method true only. After 5 seconds, is alive method will return false only. Let's start the execution of this program, thread 6. Now you can see thread 1 started, thread 2 started. Child thread 1 is alive true, child thread 2 is alive true, thread 1 is ended, thread 2 is ended, child thread 1 is alive false, child thread 2 is alive false. So threads are ended, that means is alive method is false. Threads are started, is alive method is what actually true. Once I run this again, now you can see, again once I run this, so is alive false and true is available. Okay, this is the case. Is alive false, false. Is alive true, true. Got my point? Yes. So this is the child thread is active mode or not active mode. We can able to find easily here. And one more last method is there, one important method for today's session. Then we'll close this. Thread 7. That is join method is there, sir. JOIN join. JOIN join method is there. What is the join method is there? In the first previous session, we include join method also in our programming. So what is the join method? You can see if a thread wants to wait, if a thread wants to wait until completing completing some other thread, until completing some other thread. If a thread wants to wait until completing some other thread, then we should go for join method. Then we should go for JOIN join method like this. We should go for join method. If a thread wants to wait until completing some other thread, then we should go for join method. Okay, for example, let us consider this. From threading import star. From threading import star. Import time. Import time. df f1 function here. For I in range of 10. For I in range of 10. Print child thread, I can say that. Child thread. Time dot sleep of 2 seconds I'm waiting. Now t equals to thread class. T is an object. Target equals to f1 function. Okay, t dot start. Now observe here. This is clearly execute. There is no problem at all. Why? Because here right now in my program only one class is there, one child thread object is there, only one child thread. This child thread object is going to be targeting f1 function. It's fine, sir. There is no problem at all. Okay, every time it is executing child thread, it's clearly executing or not. Yes, there is no problem at all in this case. The reason is we have only one thread and we have function called f1. That thread always will hit the function called f1 only. Fine, it's good. Okay, look at here. There is no problem. But what happens if I include one more loop here, which is going to be pointing for the main thread for I in range of 10 and print what I'm trying to take here. You can see main thread, main thread. Let's run this. Now you can see. Now you can see the execution output. Main thread, child thread, main thread, child thread like this. Okay, main thread, child thread, main thread, child thread. Main thread is not waiting until completing of child thread. In the above example, main thread is not going to wait. It's going to be completely executed after that. You can see this main thread is waiting for child thread. No. Child thread executed, main thread executed, again main thread, again child thread like this. So there is no waiting period for main thread for child thread here. But if you want to make wait what thread, main thread, for which thread, child thread, until completing of child thread, if you want to make wait for main thread, then we can use join function, where we can use t dot join. I am using jyn join. This line number 11 executed by which thread? Main thread only. So that main thread can wait for child thread until completion of this thread. Look at here this program. Now let's run this. First main thread is not going to execute. Why? The reason is what? Your main thread is waiting for which thread? Child thread. How much time? Until completion of child thread, main thread is waiting using join method. But how long main thread is waiting? Total until completion of child thread, then main thread is started here. You can see main thread is started. But sir, we can also decide the waiting period. So how many seconds do you want to wait main thread for child thread? I'm giving my time period is in the join method 5 seconds only, sir. 5 seconds means in this case, main thread will wait only for 5 seconds for child thread. Main thread will wait only for 5 seconds for child thread. No much more that. Now you can see 5 seconds only main thread will wait. During the 5 seconds period time, child thread will execute and remain main thread immediately executed. Rest of the time again child thread will execute. So we can call join method with the time period also. How much time you want to wait for child thread, you can decide by using join method here. This is the join method. Suppose 8 I'm taking. 8 is nothing but 8 seconds. So I am going to wait 8 seconds for child thread. Who is going to wait 8 seconds for child thread? Main thread is waiting 8 seconds only. After 8 seconds, immediately main thread is executing. Then child thread also started. So these are the methods available in threading concept. Join method, it is used to wait for other thread, and is alive method. This method is used to check whether thread is still executing or not. True or false it return. Active count method is there. This method is used to find the number of active threads. How many currently active threads are available in your program. And thread identification number, every thread is having its own unique identification. Main thread is having unique identification, child thread also is having unique identification. By using ident variable through, we can find out. So this is about today's session. In tomorrow, we'll go for thread synchronization mechanism. That is important. Synchronization. How we can go for thread synchronization mechanism. Different techniques are there. Synchronization technique like lock technique is there, or lock technique is there, and semaphore. Okay, semaphore technique is there, and bounded semaphore also there. These we will complete in tomorrow. Like, yes, this is bounded semaphore. Lock, or lock, semaphore, bounded semaphore. Okay, yes, we'll discuss this in tomorrow session. At any cost, by this weekend, I'm going to finish your Python 8 a.m. batch. After that, mostly Monday or when Wednesday onwards, I'll start new batch of Django at 7 a.m. Sorry, 7 a.m. No, this is 7 a.m. batch. I'm going to finish by this weekend. Once I finish this, immediately I'll announce new batch of Django with REST API 7 a.m. morning.